Let's build a brass sound using operator and additive and subtractive synthesis. Here's what the brass sound could sound like. Okay, let's see how this patch is built. So under global controls, I'm using additive synthesis. This middle section is just set to the default settings, so we don't need to change anything here right now. Voices I have set to 8, voice polyphony. You can have more or less. I do have retriggering engaged, as well as interpolation and anti-aliasing. My tone is set to 70% and my volume is set to minus 18 dB. You can play with these settings as according to what you like. This patch uses 4 oscillators and it does use a filter. I'm going to turn off the filter for right now and we'll come back to this. So let's just start with the oscillators. So if we look at oscillator A, we can see that the coarse setting is set to 1, the fine setting is set to 5. I do have it set to minus 12 dB. I'm using in terms of the oscillator, I'm using a saw D wave. And for the envelope, we are using a pretty, there's not much of an envelope actually. It's just 0 attack. My initial dB is set all the way down here. Then a 600 millisecond decay, peak of 0, 50 millisecond release time, and a sustain of 0 dB. Now the only other thing I'm adding to this is I'm adding a little bit of velocity control. And what this will do is this number can range between 0 and 100. 0 meaning that the velocity of the note I'm playing on my MIDI keyboard, or any velocities that are set in a MIDI clip, will help determine the overall level of the oscillator coming out and what we're hearing. So this can affect the timbre, obviously. So in terms of if we want velocity to have some control over that. So experiment with this setting. You could set it to 100%. You could set it to 50%. I'm suggesting start at 30%, and then we'll just go from there. When I compare oscillators A, B, C, and D, if I click on these, you can actually see that the display window is all basically the same for all of them. And so the only difference in each of these oscillators is actually in the coarse and fine setting. So very quickly what we can do is we can copy the settings from A into B and C and D. And so all we do is we click on B, make sure I'm looking at the envelope, not the oscillator. So I'm going to click on envelope. And then if I control click on here, I can copy everything from oscillator A. So don't copy just the envelope, but copy everything from oscillator A. And then do that for C and D as well. So all the settings here in the display area are exactly the same for all the oscillators. And then all we have to do is adjust the fine tuning and coarse for each oscillator. For B, I'm setting my coarse to 0.5. My fine is set to 995. For B, coarse is 1, fine is 10. For D, coarse is 0.5, and fine is 990. Now let's hear how these sounds kind of build up. So here's just oscillator A on its own, and again I have no filter here. So I'm just hearing this very electronic sounding sawtooth wave. Let me add B to this. So because they're slightly detuned from one another, we're getting some beating. And I can adjust the amount of beating by adjusting this fine tuning. So experiment with this a little bit. So I'm going to set it back to 995. You can adjust this fine tuning by just adjusting this here, or if you click on it and then type a number and then hit enter, that's another way to adjust this number to get it really precise. So that's A and B. Let me add A, B, and C now. And then finally D. So there's lots of beating. Each of these is sort of reacting to the other. Remember, this is not frequency modulation where the oscillators are modulating each other. This is amplitude modulation. So we're hearing each of these tones on their own, but because they're slightly detuned from one another, it's creating these beating patterns from them just being out of tune. So this sound on its own it's fine. It's just very electronic. And so if I want to make it more of a brass type sound, I'm going to apply the filter now to this. So let's do that. Add the filter. And you can see that in terms of the filter slope, I've set this to 12. You can try 12 or 24, see what you like. I am using a low pass filter. You could try different filter types and see what you get and see if you like it, if you like the sound better. I do have the circuit type set to PRD. You can also experiment with different settings for this. I'm starting with a frequency set of 825 hertz, and my resonance is set all to 0. So, so this is the envelope. Here's the actual filter. So you can see if I adjust the resonance, right, I can do it from here, or I can also click on here and do that as well. Let me look at the envelope, because this is actually really important, because you'll actually notice that the envelope has a much different shape from the oscillators. So there's my oscillator A, which that's the envelope for the oscillator itself, but I'm also now applying an envelope to the filter. This is a really cool thing in Operator, that we have sort of independent envelope control of the filter as well. So for this, let me break this down a little bit. So we have a 44.7 millisecond attack. So, pretty quick but gradual attack. My initial is set to 0%. My decay is 315 milliseconds. And the peak is set to 100%. My release is set to 50 milliseconds. Sustain is set at 78%. Now let me explain what's kind of going on in this area a little bit. So we can also use an envelope the envelope to control the filter frequency. So you can experiment with this value. Try 32%. That's what I'm starting with here. You could try 20% or 10% or 0%, and obviously you could even try 100%. So see how that works, and pay attention to the oral result if you like it or not. Also, you can adjust the filter drive, and I'm going to talk about these down here in a second too. So filter drive is really kind of the loudness of the sound. So I have it set to 8.25 right now. Let me play a note and just adjust this. So I'm going to keep it around 8, but you can find a nice setting that you like too. Maybe you like 4 better or something. And then these two settings down here, what we're doing is we're adjusting the filter frequency with both velocity and the actual note we're playing on our MIDI keyboard. And again, this could also be coming from a MIDI clip as well, the velocity from the MIDI clip, as well as the actual notes that are being played by the clip. So this is a nice way to add a little bit of variance where these are modulating the note based on the note that we're playing. So again, you could have these set to 0. You could have them set all the way to 100 or some range in between. So what I'm suggesting is start with the frequency velocity being set to 36, and then the key, the note that I'm playing on the MIDI keyboard, set to 50%. And so that's it. Experiment with these here. You can experiment with filter types. So try some different filter types if you like. You could try some different filter slopes, as well as adjusting the frequency and the resonance. And of course, in we can adjust this on the fly in a performance or add automation to this and all kinds of fun things. That's a basic brass sound built in Operator using additive synthesis with some subtractive synthesis.